Assalamualaikum and a very good day. Today, me and my team are going to present about Attendance Management System AMS for subject BITP1323 database. Firstly, let me introduce myself, me, Hanisha binti HARRUN, and my other group mates, which is SITI Aishah, ISMA ANNISA, IZZATI AMIRAH, and Nur ANNISA. For the introduction part, MSU proposed to develop an attendance management system, AMS, to replace and improve the current system of students' attendance taking, which was previously done manually. It is also to ensure all the information of each student is more secure and safe. Also, it is easier for all parties to access the system anytime and anywhere.
We have three problems. First one is manually recorded. So the manual attendance system involves students filling out attendance sheet by hand, which can be easily manipulated, not secure, and prone to errors. In addition, lecturer manually save and analyze attendance data using document files and Microsoft Excel, which can leading to problems during the auditing process and data transfer. Second, loss or misplacement of student data. So this traditional method actually is out to date and can prone to the loss or misplacement of student data. This can result in administrative issues such as inaccurate record keeping and difficult in tracking student progress. Thirdly, time consuming. So the manual method of recording attendance is time consuming for students as they have to sign their names individually and pass to the student from one student to others. Okay, next, objective. We have three objectives. First one is to develop a client or server like system, namely attendance management system. Second, to allow administrator to edit, view, delete, and anything on attendance reports. Thirdly is to allow students fill in the attendance. Proceed with the scopes. We have three scopes. So first one, to develop a system, namely attendance management system, which to give the access by students and lecturer, and the system use MySQL for the database. Second, to allow the administrator to perform various action on student attendance report. So the lecturers or admin can log in using their credentials and access a home page with buttons for viewing, editing, deleting, and analyzing attendance data. Lastly, to allow students to fill in attendance, which is the students must log in using their student ID and password, and then students also can view their attendance data. If a student fills in the attendance, the system will display the word present. If the student does not fill in the attendance, the word absent is displayed, indicating their absence.
Next, let's go to significance. The system highlights the value that may be provided by project result in the field or real-world practice. The section highlight of the positive contribution of the existence of a student attendance system for use by lecturers, students at the university. This app, firstly, it is an easy access. It is automatically recorded, saving time. It gives very many benefits to lecturer, and challenge of manually tracking attendance can be prevented. The attendance system that has been introduced is one way for students to explore more about computer technology. Nowadays, attendance requires students to enter their data using computer operator controls such as Google Form created by their lecturers. It is not only beneficial for students but also for lecturers so that users do not need more time to fill in their attendance because all the data that has been entered by students is presented by technology. Next, it is paper-free. It is save time, money, and resources lost due to human error. Teacher will be also notified immediately anywhere and anytime. For a smart flow is guaranteed by an online attendance management system for universities. Whenever a student is absent, the system immediately notifies and informs their parents. Therefore, unlike conventional procedure, the university does not need to contact or inform parents. A platform can be used by university to manage student information, teacher shifts, and class timetable. Lastly, it is high accuracy. It is more accurate and much faster. It eliminates human error, easy monitoring, and tracking real-time attendance. It also helps teachers to focus more on their other tasks. Manually managing attendance data usually takes a long time and with many students is quite tedious indeed. With online attendance, this can improve efficiency from taking attendance manually. Lectures in university management can monitor student attendance easily.
Okay, now I want to explain about the database design. Okay, for the database design, there are three main points. First is ERD, second, data model, third, data dictionary. Okay, for the ERD, there are five entities. First, entity attendance, second, entity student, third, entity class. For the fourth, entity is a subject and the last for the entity is a lecturer. Okay, in the entity attendance, there are a few attributes such as attendance ID, student ID, subject ID, attendance day, attendance time start, attendance time end, and attendance status. For the attendance ID, it is a primary key, and for the student ID and subject ID, it is a foreign key. Okay, for the entity student, there are also a few attributes such as student ID, student name, student email, student phone number, student username, and also student password. For the student ID, is a primary key. In the entity class, there are also a few attributes such as class ID, subject ID, student ID, and also class name. For the class ID, it is a primary key, and for the subject ID and student ID, it is a foreign key. For the entity subject, they are also have attributes such as subject ID, subject name, course name, and also lecturer ID. For the subject ID, it is a primary key, and for the lecturer ID, it is a foreign key. Entity lecturer, there are attributes such as lecturer ID, lecturer name, lecturer email, lecturer phone number, lecturer username, and also lecturer password. Lecturer ID in the entity lecturer, it is a primary key. For the relationship between attenders and student, it is used with relationship. The relationship between attenders and student is one-to-many. For the attenders and subject, the relationship also use a with relationship. And the relationship between attendance and subject also one-to-many. For the student and class, it is used a strong relationship. And the relationship, it is one-to-many. And the subject and class, it is used also use strong relationship. It is used one-to-many. And the last one is between subject and lecturer. For the subject and lecturer, it is used with relationship. And for the subject and lecturer, it also used one-to-many. Okay, for the business rules, there are 8 business rules. Okay, the business rules is comes out from the ERD. Okay, the first one is a student has multiple subject. Second, each subject can have multiple student. Third, lecturers teach multiple subject. And next, each subject has a lecturer. And also, a student has multiple attenders. The sixth business rules, each attendance has a student. Next, a subject has multiple attenders. And the last one for the business rule, it is each attendance has a subject. Okay, the last one for the database design, data dictionary. For the data dictionary, there are 5 tables. First, student. For the student primary key, it is student ID. Foreign key, it is no foreign key. For the attribute, for the student, student ID, student name, student email, student phone number, student username, and student password. The data type in the student use varchar. Okay, next, table lecturer. For the table lecturer, the lecturer ID, it is a primary key, and foreign key, it also no foreign key. Okay, for the attribute lecturer, lecturer ID, lecturer name, lecturer email, lecturer phone number, lecturer username, and also lecturer password. For the data type for lecturer, it also use varchar. Okay, next, class table. Okay, for the class table, class ID, it is a primary key. For the foreign key, student ID and subject ID. For the attribute, class ID, class name. For the data type for the class table, is also use varchar. Okay, next, subject table. For the subject table, the primary key for the subject table is a subject ID. Next, foreign key. Foreign key, it is a lecturer ID. Attribute, subject name, and course name. And the last one is a data type, also use varchar. Okay, the last one for the data dictionary is attendance. Okay, the attendance table use primary key as attendance ID, foreign key as student ID and subject ID. For the attribute, attendance date, attendance status, attendance time start, attendance time end, and also attendance day. And the data type for the attendance table use varchar. For the varchar, use for attendance ID, student ID, subject ID, attendance status, attendance day. For the date data type, use for attendance date. Timestamp use for time attendance time start and attendance time end.
Hi, my name is Nur Anissa with AJIB, and I will explain about structure query language known as SQL. In SQL, it can be divided into two, which are data definition language (DDL) and data manipulation language (DML). Let us go deep into each of them, starting with DDL. The function of DDL is to define or modify the structure. Some common DDL statements include create, alter, drop, and each of them has its functionality. We use create command to create database objects such as table. Alter is used to modify the structure of an existing database object, and drop is used to delete or remove a database object. Next, DML is defined to manipulate data. Some common DML statements include select, that used to retrieve data from one or more tables, insert, that used to insert new record, update is used to modify existing record, and delete is used to delete specific record. This is example of DDL and DML statement. We can see that DDL statement that been used here are the create statement, which is create table student. Next is the DML statement that used to insert command to insert new data in the table. Let us go into the first question from selection and projection operation. The question is, list all the names of the students who are in Amanda class. Given a statement of the SQL is select which student ID is attribute that selected from table class, and the output was given as in the slide.
Okay, for this question, list all the student ID who are status absent in the attendance table. Okay, the output result for this question is a student ID, such as S02, S03, S04, and also S05.
Next, for the question of selection and projection, the question is find subject ID, subject name, course name, and lecturer ID for student whose course name is civil. Here we can see the SQL statements and RE, and here display the output of subject ID, subject name, course name, and lecturer ID for all students who takes course civil.
Okay, first question sounds like list the student ID who enrolled the subject CSC 1113. Okay, for this one, in summarize, the expression of student ID retrieve the value from the class relation where the subject ID is CSC 1113. So it will represent a query to find the student ID of those who have enrolled in the subject CSC 1113. Okay, this one is output for the student who enrolled the subject CSC 1113. Okay.
So for selection and projection for question 5, list attendance ID, subject ID, attendance day, and attendance status of student who attendance status was absent. So this is the SQL statement. It selects what the questions needs from the attendance where the attendance status is absent. The relational algebra is like this, projection all the what the question needs, and sigma the attendance status who is absent from the attendance table. So this is the output. The output shows the attendance ID and subject ID where the attendance status was absent.
And grouping operation. Display how many subjects are taught by lecturer. Given the SQL statement, lecture ID and subject ID is the attribute that is selected to count the subject from the subject table.
For this question, how many students are in an ungrade class? Okay, the output result for this question is use count student ID and the output is 4.
For the next question of aggregation and groupings, the question is display total number of subjects for each course name. We can see the SQL statements and RA here, and it displays the output, which is course name and total subjects.
The question sounds like displays the total attendance status of student who has attendance is absent. So for this one, the query will retrieve the student ID and corresponding count of absence for each student from the attendance table. So it will only consider the attendance record that are marked as absence. So the result will include two columns, student ID, which is containing the student ID, and second column is total absence, which is containing the count of absent for each student. So the grouping will ensure that the count is calculated per student. So this one is output, student ID, and the total absent for each student ID.
So next, this is the aggregation and grouping for question 5. The question asks to display the total number of students who take CSC 1113 and MAT 1212. So for the SQL statement, it select the count subject ID as total student, which is the total student will be counted by the subject ID from table subject, where subject ID equal to CSC 1113 or MAT 1212. So the relational algebra statement, PR is the rename for the select statement, and aggregate the count subject ID and sigma subject ID equal to CSC 1113 or subject ID MAT 1212 from table subject. So the output will show the total student who take CSC 113 and MAT 1212, which is 2 students.
Inner and outer join operation. The question is retrieve student ID, student name, attendance day, and attendance status where attendance status present. The SQL for inner join given is to retrieve data from two tables which are attendance and student. Inner join is used to combine records from the attendance table and the student table where the student ID column in both tables match, and the output is given as in the slide. Same goes to the outer join. The only difference is the query select the student ID, attendance day, and attendance status column from the student attendance table respectively using a right outer join. It retrieves attendance information for students and includes all students from the student table regardless of whether they have attendance records. If there is a match, the attendance information is included.
Okay, here are the question for the inner join. Okay, for the inner join, output is a student name, Alia binti HARRUN. And the question for the outer join, retrieve the name of student that present on Monday. The output for the outer join, student ID, student name, attendance ID, attendance date, and also attendance status. There comes out all the data for the 5 students.
For the next question of inner join, the question asks for retrieve student email and student phone number using student ID of student who in class Amanda03. We can see the SQL statements here and the RE, and it can display the output, student email, student phone number, and class ID. Next, for the outer join by using the same question, We can write the SQL statements like this, and the RA can be seen here. And the output is the student email, student phone number, and class ID.
Okay, inner join. For inner, the question sounds like retrieve the list of students who have been absent less than 2 times. For inner join, the query will retrieve all the columns from the student table for the students whose attendance status is absent and who have fewer than 2 absences. So the join operation will connect the attendance and student table based on the common attribute student ID. For outer join, uh, it will retrieve all the columns from the student table for the student who do not have any attendance record marked as absent or have fewer than 2 absences. So the left join is used to match the student with the attendance records and where class filters out the rows where there is no match. Alright. This one is the output. Okay. This one is the output for inner join. This one is the output of outer join. It was like the different output we get at the inner and the different output at the outer.
Okay, so question 5 for inner joins. Retrieve lecturer ID for student with ID S03 and display student name and course name. For the SQL statement, select the student ID, subject ID from attendance table, and course name from the subject table. This will combine attendance table and subject table in one table from using by using the subject table subject ID as the connection where the student ID from attendance table is SO3 and the relational algebra statements trying the it's a rename student ID, student subject and course name and using the student ID and using the subject ID to combine two tables and where the student ID is O3. So the output is showing like this. The student is O3, student ID and student subject from the attendance table and the course name from the subject table. And for the outer joins, the SQL statement is like this. Select the student ID and subject ID and also the course name from the attendance, which show the left of the join subject using subject ID, which is it's same like the inner, but the difference is the outer will show everything besides the inner. So this is the output.
Nested operations. The question is construct the relational algebra and SQL single row subquery statement to display the student ID, student name, student email, student phone number, student username, student password whose class name is the same as the class name of Badrul bin Azman. The given SQL query retrieves student information from the students table based on a specific condition. We specify the table we are retrieving data from, which is the student table. The alias S is assigned to the student table to make the query more readable. The outermost condition where S.student ID filters the student records based on their student ID. The first subquery is to retrieve the student ID of the student with the name of Badrul bin Azman. The second subquery is to retrieve the maximum value of class name from the student ID obtained from the previous subquery. Please find the latest class name associated with the specified student. The third subquery is to retrieve the student ID of the student who are enrolled in the class with the maximum class name obtained from the previous subquery. Overall, the query selects the specified columns from the student table for students who are enrolled in the class with the maximum class name associated with the student name Badrul bin Azman.
Okay, for this question, construct the relational algebra and SQL statement to display the student ID, student name, student email, student phone number, student username, student password, whose attendance status is the same as the attendance status of Sarah Binti alias. Okay, the output for this question is student ID, student name, student email, student phone number, student username, student password. That the status attendance same data for the Sarah Binti alias. Okay, the same data is Arina Binti Amin, Badrul bin Azman, Koyu bin Hussein.
For the next question of nested and subqueries, the question is display student ID and subject ID for a student who is present on Sunday. We can see the SQL statements like this and the RA And we can see the output here is student ID and subject ID, which is student S05 that is present on Sunday.
The question sounds like construct the relational algebra and SQL multiple subquery statement to display student ID, attendance day, and attendance status. So for this one, the student ID, attendance day, and attendance status column it will be retrieved from the attendance table for the attendance records of students who are marked as absent. So the subquery select the distant student ID values of students who have attendance record marked as absent, and the outer query filters the rows of the attendance table based on the subquery result. So this one is output student ID, this one is output attendance day, and attendance status.
So lastly, question 5 for nested subqueries. The question asks you to construct the relational algebra SQL subquery statement to display lecturer ID and lecturer name who teach subjects in class and grade. So the SQL statement, we will write it from the bottom. Select subject ID from class where class name equal to grade. Select lecturer ID from subject where that subject ID in class before, and select lecturer ID, lecturer name, and from lecturer where lecturer ID in table subject before, and the relational algebra will show like this. And the output will show the lecturer who teach class Anggrek, which is lecturer L01, Saiful bin Abdul Samad, and L03, which is Ko Sintong.
Next, for the conclusion parts, firstly is the system contribution. It is easy access for students and lecturers, elimination of manual attendance recording, provision of real-time attendance data, time and effort saving in managing attendance, promotion of paper-free practices, enhancement of accuracy in attendance records, implementation of access controls for improved data security, and lastly, encryption measures to safeguard attendance data. Next, for the system drawbacks, it is initial implementation costs, technical support and maintenance, learning curve for users, and lastly, reliability of internet connectivity. Lastly, the suggestion for improvement is firstly user training and supports for teachers and students. Mobile application is easy to use. Integration with student information system, data analytics and reporting, integration and biometric technology, and lastly, continuous system evaluation and updates. Thank you for watching our videos.